Today, 10.2, day number 1, angle of elevation, angle of depression. We're going to use SOHCAHTOA because it's good for your brain and for math. Last year, I think instead of Captain U, if you know what I'm talking about, I used Spider-Man and the Green Goblin and like this massive baby with a huge head and one hair on its head. That is not Caillou. Do not bring Caillou up in this class. I will lose it. That child whines all the time. That baby?
Yeah. The Green Goblin's closer in.
Okay, hold on. Continue. All right. So, brief pause there. Angle of depression, angle of elevation. That's our goal for today. What I'd like you to do with a neighbor is just for a little extra practice, go ahead and do these. We'll take a minute. We'll go over some answers. We'll cover them, and we'll keep moving. Go. Ba, 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 ba. Da, 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 da. Yay. All right, how we feel about that one? Eh? Eh?
Good.
Pretty good? Okay. All right. How about a volunteer for the other one over here? What we got? Is this short leg or long leg? Short leg. So short leg to hypotenuse. You had your hand almost in the air. You have to answer. Yeah. Yeah. So 14 root 2. We just double it. Right? Double that. Now, if I multiply two radicals together, like say a square root 2 and a square root 7, that's a square root 14. If I add those two radicals together, farmersonly.com does not allow me to combine those two. They're not compatible. They can't, it doesn't work. The only way this would work is if I had 2 root 7 plus 3 root 7. That would be how many roots of 7? 5 of them. Okay? That's okay. farmersonly.com. That's not. Okay, so here I'm going to multiply this. I'm going to multiply this by the square root of 3, and I should get 7 square roots of 6. All right, bearings versus true bearings. I have to teach you a language, basically. And I speak a couple different languages. One is English. The other is actually backwards language. And I learned this language sitting in a Dodge Caravan, taking constant trips like 3 times a year from Minneapolis to Chicago because we lived in Chicago and my grandparents lived up here. So I couldn't sleep in the car because my brother's feet stunk so bad. And my sister laid out in the back seat in the way back, you know what I'm talking about? So I had the short seat with my brother. His shoes were off and he could sleep anywhere. So I'm sitting there, my dad's driving, my mom's sleeping, brother's sleeping, sister's sleeping, and I'm sitting there just breathing in this toxic air. I said, Dad, how do you do it? You know, like you're driving all the time. He goes, well, I read the billboards backwards. So I would read all the billboards backwards. Like Comiskey Park is Krapyuk-Simak. Wisconsin Dells is Slednis Noxu. My name is Naskivdal Kramurakas. I know. It's weird. Yeah. Nasselrak Akol. Nasselrak Akol. Joey Johnson, Nasna Joij. Yep, Nasna Joij. Now, if someone's going to say, my last name's ridiculous, make them do it, then I'd have to probably spell it out. But, yeah, I got used to saying, like, Wisconsin and Minnesota, Etasanim, Minnetonka's, Eknotanim. Yeah. Now I'm going to teach you a third language. It's called True Bearings and bearings. Okay, so let me teach you what this means right here. What's what backwards? Oh, that would hurt. That would hurt. Okay, so north 70 degrees west just means face north, turn 70 degrees to the west. Okay, so I'm facing north. I'm going to turn 70 degrees to the west. This would be my new bearing. With me? Okay, true bearings. True bearings are for right-handed people only, not lefties. Okay? So true bearings mean you face north and then you turn to the east until you hit said bearing. So north 70 degrees west would be the same as what true? What would that be? 290 true. 290 true. 290 true. Okay, will you with a neighbor try these? Okay. Try to fill in the missing blanks and then we'll check them. Go. For each of the angles in blue, they're locked in. There's only one way to write a true bearing, right? But if given a true bearing, is everybody good on these blue ones? Are we pretty good there? Solid? But if given a true bearing, there's an infinite number of ways you can get to it using just bearings. Now, you could be really annoying and make your teacher think a lot and do like, west 1048 degrees east. Wait, would that work? No. North, right? You could make it really difficult or you could go optimally. What is the optimal, when working with true bearings, the optimal starting direction? It depends. Right? It depends. Where is that true bearing ending up? If it's a true bearing that's less than 90, just use north that many degrees east, right? Because it's always the same. If it's in the second quadrant down here, or the fourth quadrant down in the old southeast, right? Then maybe use east so many degrees south or south so many degrees east, right? Minimize the amount of calculation you have to do. So let's take some answers for 85 degrees true. Anybody? Did anybody go boring and say north 85 degrees east? Oh, you boring individuals. That's okay. I respect it. What'd you do, JJ? Okay, cool. Did anybody go east 5 degrees north? Yeah, okay, that's what I'm talking about. Small numbers, okay. East 5 degrees north. Cool. How about 210 true? Got some answers for 210 true? Yep, what do you got, Anna?
I got S 30 degrees west.
Sure, south 30 degrees west. I like that. That's a good answer. Okay, if you end up in the same spot, I don't care how you get there. You just have to do more work depending on how much that requires of you. Okay, bearings, good. Probably less exciting than my story, but that's okay. Okay, let's talk angle of elevation, angle of depression. The angle of elevation is an angle formed with the horizontal and an upward facing angle. So say an individual who's obviously massive, not proportional to this building. They are a large person. They're like 17 stories tall. Let's see. Yeah, they're really tall. But let's say they're sitting on a bench and they look up at the top of the building. They have elevated their eyes. This would be the angle of elevation. This is the angle of elevation. Okay, likewise, some small baby or maybe kids writing a comic book standing on the top of the building. They look down. This is the angle of depression here. Angle of depression. Okay. And the angle of elevation and angle of depression will always be formed by a horizontal line and some ray that is heading either downward or upward, depending on the location that we're looking at. Is that something that you've seen, HA? Yep, good. Okay. We're going to do some word problems. Isn't that fun? You all like reading, don't you? I don't. I like books on tape. I need to listen to it. I know that there's 5 paragraphs in a 5-paragraph essay. That's about as far as I go. And I was surprised I knew person, place, or thing for Nick over here. That was pretty impressive to myself. But okay, continuing. Let's go. Find the angle of elevation from a bench to the top of an 80-meter high tall building if the bench is 105 meters from the foot of the building. Okay, so I gave you a nice little sketch there, but I'm going to just totally make this look terrible and sketch it again. Okay. Here's my boring building. Oh, shoot, I screwed it up already. And then here's a little door at the bottom. And And here's my bench. Looks more like a caterpillar. Okay. 105 meters here. Building is 80 meters tall. And what am I looking for? That angle. Would that angle be at point A or point B? At point B. This is our angle of elevation. Please, with a neighbor, would you find that angle using your calculator? Or if you already know, then don't. How'd we do? How'd we do? Can we give a thumbs up to that? All right, good. Whenever finding an angle, you're going to be using your inverse trig functions. Inverse trig functions find angles. Okay, regular trig functions find ratios. All right. Now this is a JV type problem. This is an R2. Okay, easy setup. The next page is an R3 type. I want you to take a look at that. I would probably take a different perspective at it, like a, what do they call it on maps? Topological, whatever. The map view or the satellite view, right? I would sketch it out like this. Let's just talk through the first piece of it. Here's the road. Here's the top of the tree. Okay, and am I recording? Yes, I am. Okay. I've got 2 points on this road, point A and point B, and it says how far apart are they? 400 meters. Okay. Oh, gosh. Okay, and then it says something about their angles. What are the two angles? North something, right? Somebody tell me. North?
36 degrees, 40 feet.
North, 36 degrees, 40 minutes. Okay. East. Okay, and the other one says what? 33 degrees, 22 minutes. Is there direction put on it? East, south? Okay, which one would have to go with which here? Well, would the north 36 go with B or A? It'd have to go with A, right? Because if I'm facing north and then I turn to the east, this angle right here, let me mark it with a different color because children like colors. This angle would be north 36 degrees, 40 minutes east. Okay, the angle formed up here. This is where it gets kind of dicey McDicerton. Stop, I know you guys talk like that. This is your angle east, whatever, Joey, just because it's your birthday, you can fire things off like that. Yeah, I know. Okay, now what we want to do is we want to find this length. That's the goal. You want to find the closest distance that the tree gets to or is to the path of the runner. I'm going to just kind of let you go there. I'm going to get grocery store gains prepped. Okay, you with me? Work.